Okay, these are section 1.3.1 notes. We're going to start talking about your first essential skill, really, angle pair relationships. So this entire video is going to come directly from your notes framework. So we're not going to be going to the textbook on this one. So just some definitions here. So we know that a point is technically one-dimensional, which I know is kind of strange because we write in a two-dimensional space or a three-dimensional space. But really it's more of how we label it. And so we label them with a single capital letter. So that's something to keep in mind. A line is going to extend on forever in both directions. A line by definition is always straight. So curved line doesn't really make any sense. And we can think about them a couple of different ways. You can use different points on the line, typically one or two, multiple points, actually maybe three or four, just depending on how complicated the line is and with how many other things intersect the line. Or we can just use a lowercase letter. It's normally italicized. So with a line, we go through, and the naming of them, we do use, it looks like a straight line segment with two arrows on the end when we're identifying them. A line segment itself has a clear beginning and a clear ending. So I'm going to highlight these just a little bit differently because I want to use the previous picture. So if we have line segment DJ, that strictly has a beginning of D and an end of J, just so you know. And then we also have a vertex, and a vertex can be seen as a corner. So it's where two line segments or two rays or two lines intersect each other. And with those, whenever we're identifying a vertex or vertices, we can use one letter to identify the corner, or we can use multiple. And there are going to be times where we definitely want to use multiple, just like you did last year when you did flowchart proofs for the first time. Okay, moving on, a little bit more vocabulary. When we talk about the measure, so an actual size, we want to attribute some sort of a numeric value to something. We are going to use this lowercase m in front of the angle marker, and that just means the measure of. Whenever you see that, you definitely want to equate it to, on the other side, some sort of numeric value. Array itself, just in general, go ahead and do a little sketch for you here. Array is kind of like a line segment, I guess is the best way to put it, but it extends in one direction, not in both. So an example of array kind of looks like that. So we have a single endpoint and then the other one takes off to infinity. And then an angle itself, so this is where the naming of the angles comes in. You can think about an angle using a single letter to identify it. And I'll go ahead and draw one on here for you. So we can say that maybe we have angle K. So we can call this angle K, where it's not necessary to identify three different letters for it, because there is no question as to exactly what angle K you're talking about. Whereas over here in the picture that's given to you, you can't call something just angle G, because there's way too many things that are going on there. It could actually be three different angles. Actually, it could be more than that. Angle G, just angle G, which we avoid using if there's multiple vertices at that location. It could be there. So it could be that top part of the angle, or it could be the bottom part of the angle, or it could be the entire angle, or it even could be the other side of the angle. So all the way around here. So, and then there's a couple more too. So there's too many questions about which one is the actual angle. So whenever you have multiple angles that it could be, you definitely want to use the three letters for the corner. So, and always have the corner in the middle of the name. So if we take a look over here at the name of the angle G that we're talking about, we notice that the G is in the middle of the name. So kind of like the pit stop or where the actual degree is located. Okay, so that's it for our vocabulary so far. And then today we're going to cover 3 different angles and their vocabulary that go along with them. And these may sound familiar to you. You may have seen them in the past. If you haven't, that's okay. We have complementary angles. Complementary angles, when you add them together, are going to be equal to 90 degrees. One of the things to keep in mind, kind of a dead giveaway with 90 degrees, is that box in the corner that we see. So we know that the 2 different measures, when added together, we're going to get equal to 90 degrees. Now, we don't say that angle 1 plus angle 2 is 90 degrees because 90 is an actual measurement. So we would want to use that lowercase m like we have here in front of the angle marks. So one of them is going to be complementary. So complementary, 90 degrees. Okay, moving on. Now we have supplementary. Supplementary is going to be a total of 180 degrees. The dead giveaway for this one is the fact that supplementary angles, when put together, give you a straight line. So we know that the degree of a straight line is 180. So if we take a look at this, I'm not too thrilled about the notation on here, and I think we need to fix it because it is x plus y equals 180, but that doesn't really fit with our measurement notation, unless, of course, we go back to the picture and the x actually represents the degrees of that corner and the y represents the degrees. If that's the case, which I think that was the intention here, then yes, we would say that x degrees plus y degrees does give us 180 degrees. And then the last one, this one should look familiar. This is the one that, or one of the ones that you guys dealt with last year. And this is vertical angles. Whenever I think of vertical angles, I always think about the fact that it looks like a big X. And the vertical angles, so if we have this big X kind of in the middle, the vertical angles are angles that are on opposite sides of the X. So we could say that angle 1 is vertical with angle 3. And we know that vertical angles are congruent to each other. But we have another pair in here also. We could say that the other pair of angles, 2 and 4, put little markers different on there. We could say that angle 2 and angle 4 are congruent to each other as well. So the 3 vocabulary words that we're really going to handle when it comes to angle properties today is complementary, supplementary, and vertical. So really at this point, it's only 2 new vocabulary words. Okay, so now this is directly from the notes, and this is on page 8 in your notes. We're not going to go through and do all of these. I figured I would go through and cut and paste all of the ones that we were going to do. So we'll come back to A and we'll come back to B in the future, but we can deal with C right now. So the first thing that I would take a look at with C is look to see which of my vocabulary words is actually satisfied here. And in this case, I see a big X. So I'm going to go ahead and trace those guys and then just look and see where everything is in regards to that X. Well, in this case, the 2 are opposite corners of each other. So since they are opposite each other, then I know that these 2, so this angle, let's get rid of that. This angle here is going to be congruent to the angle in the opposite corner. So I know that 2x minus 10 is going to be equal to x plus 40. And I want to make sure that I know my reason for this as well. And that's because these angles are vertical angles. So I'm going to go ahead and fill that in. And then now we'll just solve the equation for x. So move your x's together. And then go ahead and move the constant to the other side. So isolate your x's just like you have done in previous years. So it looks like x is going to be equal to 50 degrees. Then if I take a look back at the question itself says find the value for x, which I just did. Now, with this whole justification of work, so I just want to make sure that we're clear on this. When I ask you to justify your work, there's a couple of things that I'm looking for. I am looking for the vocabulary word that relates them together. I am looking for the correct algebraic expression or statement. So what equation is appropriate? So vertical angles are congruent, which means they should be set equal to each other. Then the rest of the work, so the justification, is also the worked out portion and getting to the answer itself. And that's all we're going to do for A, B, and C. Okay, let's move on. So now we're at D, E, and F. Based off of the information that we have, we're going to go ahead and work on D itself. So if I take a look at D, there's kind of a dead giveaway here, and it really is that 90-degree angle there in the corner. Now, if I take a look at this, if I were to extend the angle or the rays here, I want to make sure that the angles that we're actually looking at, and I'm going to use two different colors here because I don't know that they're the same size. So this angle in orange plus this angle in blue, yes, when put together, they're going to make that box in the corner, that 90-degree angle. So I know that two angles that add up to 90 degrees is going to be complementary angles. So I'm going to say my vocabulary word. So I've got complementary angles, and then I know that these two complementary angles, when added together, is going to give me 90 degrees. Dead giveaway is that box in the corner. And then go ahead and solve. So combine like terms. I'm going to drop the angle symbol until the end, and then I'm going to add my 15 to the other side. 3x is equal to 105. Divide both sides by 3. And then if this can be simplified, go ahead and simplify it. So let's take a look and see if I can do 105 divided by 3. Yeah, it goes in evenly. It's actually 35. So x is going to be equal to 35 degrees. So make sure I got everything covered. So I have my vocabulary word, or why I get to do what I'm going to do, the equation that fits the vocabulary word that also fits the situation, and the solved equation with the answer. Okay, then we can also go ahead and take a look at D. If you look at, E, if you look at E, we have this straight line now. And then I've got these two angles. Now, I don't know if they're the same size or not, but I know that that angle in green and that angle in blue, when I put them together, I do get this straight line. Well, if I add two angles together, their measurements together, and I get a straight line, then I know that I should get 180 degrees. And the reason why is because of supplementary angles. So I'm going to write supplementary here. Now, supplementary angle, take the measurements of the angles, add them together, and we should get 180 degrees. Let's go ahead and combine like terms. Drop the degree symbol until the end. Or you can keep it. Either way is fine. That's going to give us 192. I'm going to divide by 8. See if this can divide. And if it can't, I'm going to simplify it anyway. But in this case, it actually does. So x is equal to 24 degrees. Do a quick check. I said my vocabulary word. I have the correct equation that matches with that vocabulary word, which matches with the picture. And then I have all of the correct and appropriate work to go with it. F we're going to skip over for now. We'll come back to this one in the future. Okay, and now we're on to G, H, and I. Based off of what we've done so far, I think the only one we can actually do is H. We're definitely going to come back to G and I, though. So if I take a look at H, it's a lot like one of the ones I just did. So I've got this straight line, but in this case, instead of having two angles that are being combined, I'm going to have 3. Now, I don't know how big they each are, so I'm not color coding them the same, especially the 43 and the 24. I know for sure that they're not the same. But I do know that if I add the red, the blue, and the purple, I'm going to get a straight line. So I know that the degree of a straight line is 180 degrees, so I've got this idea of supplementary angles. So I've got my vocabulary. Now I'm going to write down the appropriate algebraic equation to go with this. I'm going to go ahead and drop my degree symbols. Go ahead and combine like terms to solve for x. So I think that's going to give me 67 is equal to 180. I'm going to subtract the 67 from the other side. And I believe that gives me 113. Let me do a quick check on that. Yep. Okay. Make sure that you've covered all your bases. We've got your vocabulary word. So your justification is going to include all of these things. Correct vocabulary, correct equation that matches the vocabulary, and then correct work with correct answer. And I believe that covers your notes for today.